Hey everyone, and welcome to a new video on this channel. It's quite a while ago, so I'm happy to be back with a new video. And this time we're going to take a look at the OpenAI Assistant API that was announced during the Developer Day event in November. That API is at this point in time, so November 2023, still in beta. Now we're going to define an OpenAI assistant, and we're going to do that in the portal. We're going to define 3 actions in that assistant. These actions are defined using JSON, and they tell the model what actions are available to help us achieve a certain goal. In this case, I want to build an assistant that can help me with my Philips Hue lamps or lights around the house. So for example, I'd like to tell the model, turn the lights on in the living room, or turn on the lights in the study and set them to full brightness. Things like that. Now, in order to do that, I defined 3 actions: set light brightness, and get lights, and we'll get into the details later when I show the assistant. Then we're going to use some Python code that will refer to the assistant using its ID. That's all I need to work with the assistant in code. And then the system is going to work with a couple of concepts here. There's a concept of a thread. So for each user interaction, separate user, you will have a thread. You will add messages to a thread. A message can be, for example, the user saying, turn on the lights in the study. When you have a thread with messages, you're going to run the thread. Running the thread means that the model is going to infer some kind of response. Now, if the message is something like turn on the lamps or lights in the study, well, then I'd like the model to indicate to me that I should run the set light function in my code. So in step 4, when we do the run, the result of the run will be as follows. It will be some JSON that I can use to check if an action is required. If I see that, for example, the set light action is required, I'm going to execute the action in my code by calling an actual Python function, right? If there's no action to be done, there probably will be just messages returned by the model, then I'm going to print the messages. But if there are actions to be run, I'm going to execute them, and I'm going to also check their return message. Did the action succeed or not? For example, it might be possible that there was an error trying to turn on the Hue lamp, for instance. I want the model to know this and tell me that. That's why we're always going to report back results to the model by doing a separate run with the outputs of the actions. And more likely, more often than not, that will just respond or result in messages that will be printed. Like, for example, hey, I was able to turn on the lights in the study, or I was not able to set brightness of a certain light in the house. So I always have feedback from the model. Now, we're going to first start with showing how to create the OpenAI Assistant in the portal. Then I'm going to show you what the actual assistant looks like, and we also use text to audio and audio to text in the code. And then we're going to explain the code in the end. So stay tuned. Let's see how we build the assistant. Let's look at the assistant first. Although you can create an assistant using code and then later refer to it by its ID, you can also create the assistant in the portal, so to speak. Just go to platform.openai.com, make sure you have an account there, and then you'll find the assistants in this location here. You can easily create your assistant using the create button. I already created my Hue assistant. And again, important, the assistant ID is going to be is important here because we're going to refer to this assistant in code using this ID. The assistant has a name, Hue, and also some instructions. I have some custom instruction here to make sure that, for example, when I say floor lamp, the name of the lamp in Hue should actually be floor and not floor lamp, for instance. And other instructions might be needed depending on your setup. I'm using GPT-4 Turbo. That's not really required. You can use GPT 3.5 with function calling. But the important thing here is to define your functions. Now, the functions we define here are relatively easy. We have a function called setLight, that just requires two parameters, the name of the light or lamp in UE, and then the state of the lamp, true for on and then false for off. And I require both of these parameters to be submitted. There's also a function to set light brightness, and again here very similar. We have a light here and then the brightness, which is in this case a percentage. The actual brightness number in UE is a number up to 254, and we'll use the percentage to calculate that actual underlying number. And then the last function is get all the lights I have from the UE system, right? So three relatively easy functions. Now these functions, if you look at them, they just they provide the model with information about when you want to turn a light on or off. Well, you could actually tell the developer, I'd like to call this function. The actual function call has to be made by the developer, of course, right? That means that this is just metadata. We can actually test if the function calling works properly. So if we test our assistant, we get the playground for assistants here. And I'm seeing here that my three functions are available. With assistants, an assistant is one part of the solution, but threads are another part. Threads is what you add messages to, and then you run the thread to get a response from the model. So here we have a thread. Well, it's not created yet. I will just add a message and say, for example, turn off floor lamp. And I'm gonna use add and run. This adds the message to a thread and then performs a run to get a response from the model. Now the response from the model is now not just text. The model actually responds with, hey, you need to call a function. Now here we can't call the actual function, but I can, for example, say, well, suppose this would be a success. This is the response from the function. Well, then when I submit this, the model will then decide to say something like, hey, I turned off the floor lamp. I could say, for example, using history here, turn it back on and set to full brightness. We do add and run again. And normally now what will happen, or what should happen, is like parallel function calling. Two functions were identified. First, turn on the light, and then turn on the brightness. And full brightness is, in this case, interpreted as being 100, because in my definition of the parameter, I said it goes from 0 to 100. So the model understands 100 is full brightness. Now, if here, for example, I say success, but brightness is failure, then the model will be able to know what happened during these executions. For example, it says here, well, there was an issue with full brightness. Should I try it again? I can just say yes here. And then again, the function call will be indicated to just do try and do set light brightness again. Suppose now it is a success. So I'm going to say success. Then the model should respond with, okay, this was fine. We can continue. So this is what we want to achieve in our, let's say, custom application. Now the application we built with Python. So we have to write some code to submit messages to the thread. And when the thread indicates, or the run results in, you have to run functions. We're going to run the actual functions, of course, and then bring back the response of those functions into the thread, and then run it again to see if we get, or that we get a response from the model. We'll also add some audio to it, so we can actually ask questions using our voice, and we also get a response back, which is a spoken response. Let's see how that works. What lamps do I have in my house?
You have these lamps in your house: Salon 2, Salon 1, dressoir, study, floor, kid.
Turn on the lamp in the study and set it to full brightness.
The study lamp has been turned on and set to full brightness.
Turn it back off.
The study lamp has been turned off.
Turn on the lamps in the rec room.
I'm sorry, but it seems I don't have the specific location for rack room in the current setup. Could you please specify the exact name of the lamp or lamps you wish to turn on, or provide a different room name that is recognized by your Hue Lights setup?
Okay, now let's take a look at the actual code. Now, to interact with my UI system, I'm using this library over here, which is easily initialized by using the IP and the following code over there. From the moment I run bconnect and it connects successfully, I can use code like, for example, what you see here. I'm having things like bSetLight, and then I can use on here, true or false, to turn on the lamp or not. And light would be the name of a lamp or light as it appears in your UI app. Similar things for example, setting brightness. So I'm using this to interact with my local UI bridge on the network. And this will not work remotely when I'm running this code outside the house. Now, of course, we want to use the OpenAI Assistant, so we need the OpenAI package. I need to load some environment variables. Here you'll find that you need to have your OpenAI key, and then you just use .env to load that environment variable. For the new clients, you have to use this kind of method here. So client is OpenAI.client, and from that moment on, I can start working with the OpenAI client libraries to interact with assistants, with threads, with messages, and so on. Now, you remember that we looked at the assistant in the earlier phase or in the earlier part of the video, and the assistant had an assistant ID. So that ID is hard-coded here now. This could have been an environment variable, but it's not. And that's all I need to interact with the assistant, if I'm, of course, authenticated properly to my OpenAI account. As you have seen in the playground, you need to create a thread and then you add messages to it. And then you do a run. So we need to do the same thing in code. Here we create the thread and retrieve the ID of the thread and store it in the thread ID. Then we're asking for user input, and we will keep on asking for user input until the user actually presses Ctrl+C or something and just breaks the loop. What I'm doing here is I am using some audio helpers here. So I'm asking first to start to press enter to start the recording. You have seen that in the small demo. And then I'm getting the user's input with this get question function over there. That's defined in AudioPy, and in AudioPy we're using some tooling like PyAudio, like Wave, like Keyboard, and also OpenAI to use the Whisper model to transcribe audio to text. So I'm not going to go into detail in getting the actual audio from the system. You can look this up in the actual code. Suffice it to say that we get an audio recording, a WAV file at a certain point in time, and I'm going to use that WAV file here. I'm going to open that WAV file, right? And then I'm going to call the OpenAI APIs, use the Whisper model, and basically get the audio, the spoken text in the audio back in the transcript variable, which I then return here. Quite easy. So that means that here in UEPy, get question, the result of that would just simply be text. That's the question the user asks. There is not really any error checking here if user input is empty or not. We could add that, but in this case, we don't. So now we have the user input. We can add this user input as a message to our thread. So we use client beta threads messages create. We refer to the thread ID we created earlier. And in this case, this is a message, a question or input from the user. So role is user, not assistant or anything else. And the actual content that we add to the message is in user input, as was just explained. Now, just adding a message to a thread is not enough. I have to do a run. To create a run, we use the following code over here. Run is client beta threads runs create. Here is where we tie the thread and the assistant together. So we have the thread ID and the assistant ID, plus some extra custom instructions. For example, when the model sees that a certain action failed, it might try to directly retry the action. I don't want that. I always want the user to be explicit and ask to perform an action. You can, of course, adjust these instructions the way you want them, depending on what you want to achieve. A little bit of prompt engineering, basically. Now, this run, creating a run, is an asynchronous operation. So it returns immediately and returns information to the run variable over here. With a helper function called wait for run, we're going to wait until the run is finished. The wait for run is over here. So there's a while loop that keeps on running whenever run status is still queued or in progress. When it is that, well, then we're going to do a client beta threads run retrieve to update the run information. And we sleep every time for half a second between these calls. When run status isn't queued or in progress anymore, we can just return the finished run object here. Now, that's something that we do here. So we wait for the actual run, and then I create some JSON from that run, and I write that run to a file. I do that here just to be able to show you what such a run object looks like. And if you look in the run object, in this case, this was when I asked the question, give me all the lights in the rack room. So that's here. He determined that get lights needed to be run. Well, we can see that we need to do an action, that we need to call a tool, because required action is in the run output. If a run does not result in a required action, that isn't there, and you just might have some message response coming back to you. So my code needs to check for this required action. And I'm doing that here with the following. We're saying if run required action, well, then we're going to check what actions do we have to run. Or they actually call it tool calls. And tool calls is an array of tools to call. So I'm retrieving the tool calls using this code over here. And that means I might have one or more tool calls in that list. We're going to, before we run through every tool call, I'm going to use an array here, or a list called tool outputs, because every tool has an output and I have to submit all these outputs to the model. And if there is more than one tool, I have multiple outputs, right? So what I'm doing here is for each tool call in the list of tool calls, I retrieve the function name. And we retrieve the function arguments. That's what the model thinks I have to call. For example, set light, and then with the lamp name, and then true or false. So indeed, I can then check in this for loop, if the function name is set light, well, then we're going to go call the actual set light function in my code. And the argument that the model provides to me is the name of the lamp, that's in arguments light. The true or false is going to be in arguments state. So we call setLight, as you have already seen a little bit, that's defined in the helper functions here. We're going to indeed call setLight. Now setLight will have a response. That response might contain an error. Well, we do some error checking here. When there is an error, this setLight returns success false. Otherwise, it returns success true. And that's of course something that we are going to save here in the result. So when, for example, we have called setLight and the result is like positive, for instance, we're going to append this to our tool outputs array. So we're going to say, well, the tool call ID, this one, had the following output. In my case, maybe success true or something like that. Now again, I could have multiple functions. For example, set light brightness might also be part of the same iteration here. And then I would also have an output from that after calling this function. And that output would also be added to the tool outputs. It's important that you capture these tool outputs, all of them, because we have to present them back to the assistant. So the assistant can say, well, hey, I managed to turn on your lamps, or I failed to set the brightness, and then act accordingly. So here we are going to do another run, but in this case, the run is going to be a run with submit tool outputs. I'm going to specify the thread and the run ID, and I'm going to give it the tool outputs here. Again, because this is a run and it's asynchronous, I'm going to wait for the run and I will get some response back. So based on the response, based on the tool outputs, the assistant might decide well, okay, I turned your lamp on or off, or I failed to set the brightness, or something like that. Well, we want to see what the result of that is, and that is in the messages in our thread. Now, the messages in our thread, so client beta threads messages, those messages contain both the user and the assistant responses. And with the pretty print function, I'm going to just print them all to the screen, from the earlier questions to the last question and answer that we got. Now, in this pretty print helper function, what you'll get is the following thing. In pretty print, we're basically are going to enumerate through all the messages, and we're going to print the messages. For example, the user, the role might be user, and then I will see my question in there. The role might be assistant, I will see my answer in there, right? Now, I also keep the last message because I want to present the last answer, the last message, as audio. So here we're using the text-to-speech model of OpenAI. So I'm going to say, okay, speech is client audio speech create. The model is text-to-speech, the voice is Nova. And here is the text that I would like to get back as an MP3. What I get back indeed is an MP3. It's in speech content that contains the MP3. We convert it to a series of bytes. Then we can use audio segment from MP3 to create audio from that and then play the audio. We're using some, of course, here audio segment here, and we're using play from PyDub playback in order to play some sounds. So that's basically all the code. I'm not going to go into too much more detail here. You can find the code on my GitHub. We have come to the end of this video. I hope you have understood how OpenAI Assistant API works. We created the assistant in the portal, but you can also create it in code. And then we wrote some Python code that creates threads, adds messages, and then runs these messages. And the important thing here is the result of a message run could be that the model has determined that an action should be called. So we check for the action, then we execute the action, and we report back the result of the action in some form of chat-based application or loop. I hope you enjoy this. See you for some other video soon. Bye bye.